Hi everyone, welcome back to another video lecture from Ms. Simino. This afternoon we'll be talking about colligative properties. So one of our first objectives for this section is to identify three colligative properties of solutions. We also want to explain why the vapor pressure, freezing point, and boiling point of a solution differ from the properties of the pure solvent. And so remember why these sound like very serious objectives. We're going to go ahead and end the unit by making ice cream, and all of these objectives will help us explain why we're able to make ice cream. So when we talk about colligative properties, we're only talking about the number of dissolved particles. We're not really caring about the kind of particles. And the three important colligative properties that you're going to need to know are vapor pressure lowering, boil point elevation, so increasing that boiling point, and freezing point lowering. So since we're discussing the number of particles, remember that some particles will ionize or split completely while others will not. So if we look at this first glass, we've got some water and we've got some sugar. So as we dump these glucose or the sugar in here, remember the sugar particles stay together. So there's only one particle in solution for each particle you start with. On the other hand, if we take sodium chloride or table salt, we know that when we add that to water, we end up with sodium ions and chlorine ions. So now we have two particles in solution for every one that we start with. And sometimes we can have even more. So for example, calcium chloride here has three particles in solution for each one that it starts with. So we're going to have the calcium and then two chlorine ions in solution. So on this slide, we want to talk about vapor pressure being lowered. Remember we talked about vapor pressure when we were talking about boiling point. And so the idea here is that surface area is reduced, thus less evaporation, which is a surface property. So what they're basically saying here is, like, let's say I have this solution of particles, these black particles. What can happen is if I add the sodium chloride particles to it, we now have sodium and we now have chlorine particles in here. So there's two pieces that are now going to be in this solution. And so I'm just going to make some drawings, like let's say the red are our sodiums, and let's say the blue, which are going to be kind of hard to see on this background, are chlorines, okay? So what ends up happening is the bonds between the molecules keep the molecules from escaping. So what that means is, like, this red molecule is going to be attracted to this black one. This blue one will be attracted to this one. This one will be bonded with this. So instead of these black particles being able to escape or evaporate from the liquid surface, they're now having interactions or bonds with these other solute particles that we've added. And so since they're bonding with these other particles, okay, so since we've got these bonds going on here, they're not able to escape, and this lowers the vapor pressure. Remember when we talk about vapor pressure, that is the pressure that the gas is exerting in the atmosphere. And so if we have less stuff going into gas, we're going to have lower vapor pressure. So let's see what this says. Electrolytes form ions when they are dissolved, making more pieces. And so that's what we said about the sodium chloride. Okay, so another colligative property we have is boiling point elevation, or elevated. So the vapor pressure determines the boiling point, and so we talked about that during that one lab. Boiling is defined as when the vapor pressure of the liquid is equal to the vapor pressure of the atmosphere. So vapor pressure means you need a higher temperature to equal the atmospheric pressure. So the lower the vapor pressure, the higher the temperature you're going to need. And so this makes sense. If we're decreasing the vapor pressure, lowering the vapor pressure, well, then the boiling point is going to have to be higher. And so an example of this is that salt water will boil above 100 degrees. And notice we have salt and water. Normally, water will boil at 100 degrees, but if we're adding these salt particles, this salt is going to be interacting with these water particles, making it less vapor pressure, higher boiling point, and so that's why we're going to have a temperature of above 100 degrees. So remember, the number of dissolved particles determines how much, as well as the solvent itself, as far as what this boiling point is and how much of this colligative property these interactions are going on. Okay, and the final one that we really want to talk about is freezing point is going to be lowered. And so remember, the freezing point is the one that's going to be important for when we do the ice cream lab. So here it says that solids form when molecules make an orderly pattern, and those are called crystals, like ice crystals. The solute molecules break up this orderly pattern. So let's say, going back to my lovely drawing, we have these black particles here. So in order for these guys to form a crystal, they need to form bonds between them. Okay, they're going to form some kind of structure, some type of crystal pattern here. But what ends up happening is we have these other particles that come in and they kind of break or they interfere with this bonding process. And so in order to get these guys to bond, you have to have even a lower temperature or less movement of these particles for these bonds to form. So the idea here is you would normally have particles that would form bonds between them. You're having kind of these new solute particles come in and prevent these bonds from forming. So this makes the freezing point lower. For example, salt water freezes below 100 degrees. Again, we've got salt, we've got water. Water normally freezes at 0 degrees, but because we have the salt interfering with the water molecules, it's making it colder. It has to be colder for it to freeze or to form these crystal structures. And so then the lab that we're going to do is this homemade ice cream with rock salt. So again, how much does it lower depends on the amount of solute dissolved. So if you add just a little bit of sugar, salt, it's not going to drop that much, but if you add a lot more, it will drop exponentially. So in conclusion, remember a colligative property. I sometimes think of the word colligative like collage. So a collage is going to have different properties than just the original page would. So in colligative properties, you're putting two things together. And so how much things are lowered or increased depends on the number of particles that we have in solution. And the three colligative properties that you need to be familiar with are vapor pressure lowering, boiling point elevation, and freezing point lowered. And just remember how these extra solute particles are interfering with this bonding or with the actions that the particles want to take, such as evaporation. Thanks, guys. Good night.